Velocity and other rates of change. On page 129, exercise 2, it says a particle moves along a line so that its position at any time t is given by this function. S is measured in meters. All these numbers in the S column are meters, 2 meters, 0 meters, etc. That means how far from 0. And the t is measured in seconds. All of these numbers in the t column are in seconds. At 0 seconds, that means at the beginning of time, the particle that's moving is at 2. That's this red dot. At the end of 5 seconds, down here at the bottom, the position of the particle is at 12. So there's a particle that's moving on this line, maybe going back and forth, but at the beginning, its position is at 2 meters, and at the end of 5 seconds, it's at 12 meters on this line that it's moving on. So part A, the word displacement, part A says find the displacement. That word means the distance from where it started to where it ended. In other words, it's the position at the end of the 5 seconds, that time, minus the position at the beginning of the 5 seconds. That's what displacement means. The change in position. Change in position. So at 5 seconds it was at 12. At 0 seconds it was at 2. So these numbers are both meters. 12 meters minus 2 meters equals 10 meters. That's called displacement. Part B says find the average velocity during the first 5 seconds. The phrase average velocity means the change in the position, that's in meters, divided by the change in time, that's in seconds. Numerator is meters, denominator is seconds. The change in S is what we just did in part A. The change in time is just the 5 seconds minus the 0 seconds. So the numerator we calculated in part A, that was 10 meters. The denominator is 5 seconds minus 0 seconds, that would be 5 seconds. And this simplifies to 2. Right here are the units, right here, meters per second. That's called the average velocity over the 5 seconds, first 5 seconds. Part C, the instantaneous velocity. That phrase, instantaneous velocity, means the derivative of the position with respect to t. Notice average velocity, delta s over delta t. Instantaneous velocity, ds over dt. Which, now that we know the differentiation rules, the derivative of s with respect to t is 2t minus 3. 2t minus 3 plus 0, because the derivative of 2 is 0. The instantaneous velocity when t is 4 could be symbolized like this. ds dt when t is 4. Meaning take what we got here and 4 goes in place of t. That's 8 minus 3, which is 5. But we still look over here for the units. S is the numerator, meters. Down here, right here, t is the denominator, time, seconds. 5 meters per second, that's instantaneous velocity. At this instant, t equals 4 seconds. Part D, the phrase, the word acceleration, here's a new word. The word acceleration means the derivative of the velocity with respect to time. Where up here we called instantaneous velocity ds dt. That's equal to v for velocity. It is a function of t. So we're saying the derivative of the velocity, so the derivative of this is called acceleration. The derivative of 2t minus 3 is 2. So look at the letters here. V is velocity. Velocity is meters per second. Down here's a t, right here, t. T is time, seconds. So that since this is meters per second and this is seconds, the label here is 2 meters per second per second. That's what we call acceleration. Often written 2 meters per second squared. But it's really meters per second, because that's velocity, per second, because time is down here. And in the question it says velocity, it says find the acceleration when t is 4. Well, this is the acceleration at any time, because the derivative of 2t minus 3 is always just 2, no matter what t is. It's the derivative, it's the slope. Part E says, when does the particle change direction? So over here on the line where the particle is moving, it started out at 2 on the line, 2 meters at time 0. Eventually it ended up at 12. Well, when a particle is moving to the right, its velocity will be positive. And when a particle is moving to the left, the velocity is negative. So a particle moving on a line like this will change direction when the velocity is 0. So when the velocity is 0, that means the particle that's moving along here is stopping. It's stopping for an instant so that it can change direction. So if it's going right, it can stop and then go left, or vice versa. So part E, when it says the words, at what values of t is the particle changing direction? Interpret particle changing direction to, that means the same as the particle stopping. And if something is stopping, that means its velocity is 0. And the velocity was right here in the blue, 2t minus 3. So velocity is 0. In this problem, this is the velocity, 2t minus 3 is 0. Add 3 to both sides. Divide both sides by 2. T equals 3/2. T is measured in seconds. This is the time when the velocity is 0, meaning the particle stopped. If something's going 0 meters per second, it's stopped. It's stopping so that it can change direction. So here's the path of the particle. At time 0, it's at 2. A second goes by. I'll look down here, I did this later. After 1.5 seconds, see, it's at -2 and it's at -1/4. So it must have gone this way. And then a little more time goes by, look at this table, and it's back at 0 again. A little more time goes by, 3 seconds, and it's, let me start this over again. Starting over. At time 0, this is where the particle starts, 2 meters. Look down here, right here. 1 second goes by and it's at 0. So we're there. After 1.5 seconds, it's at negative a quarter. So that actually happens to be the time, 1.5 seconds, when it changed direction. So it stopped here for an instant so that it can, after 2 seconds, end up back at 0. And then after 3 seconds, it's back at 2. After 4 seconds, it's all the way over here at 6. After 5 seconds, it's all the way over here at 12. So it went from here, going to the left for a while, stopping to change direction, and then eventually ending up way over here at 12. So from this, we can answer part F. This was the answer to part E. Where is the particle when S is minimum? S are the numbers in this column. S is the smallest, right here at negative 2.5. The minimum, that means smallest, S is exactly, this is not a coincidence, at the time it changed direction. Negative 0.25. That's negative 0.25 meters. Negative meaning to the left of 0. That answers the where is the particle when S is minimum. Minimum, it's never smaller than negative 2.5. Because when it gets there, it stops and turns around and goes to 12 at the end of the 5 seconds. And I don't know if I mentioned at the beginning, but this table just came from plugging numbers into this formula that's given. S equals t squared minus 3t plus 2 is given. So I plugged numbers in from 0 to 5. I also plugged in the 1.5 because that's an important time. That helped us answer, well, it is the answer to part E, and it helped us answer part F.